Yeah.
Okay. So do you want to try this one on your own, or do you want me to go through it?
I'll do this on my own.
Okay.
Yeah, I'm done.
Great. So the final answer is 1/5 x to the 5th minus 1/4 x to the 4th plus 1/3 x to the 3rd plus c.
Yeah.
Is that okay?
Yes.
All right. Now it's always plus c, always plus c, always plus c.
Wait,
So this,
1/5. It's because you times it, so you flip it, right?
I guess I don't follow. You divide. Are you seeing? You're seeing my screen, correct?
Yeah.
You always divide by the new exponent.
Okay.
And my preference is to write it out in front. Now we also talked about the idea that if this is y equals here, and you take the derivative of this, you get back to the original. Oops. And so that's just something to keep in mind. The derivative of a constant is 0. So when you simplify this, you get x to the 4th minus x to the 3rd plus x squared. And that's what we started with. You don't have to do that ever, but that is totally reasonable here. Okay, so another thing we talked about yesterday is that the variable does not have to always be x. In fact, it's not often even x. Okay, now there's one little thing here that we did not talk about here, but let me just write this out separately. So it's integral 5t to the 8th dt minus the integral 2t to the 4th dt plus the integral of t dt plus the integral of 3 dt. So this problem here can be rewritten this way.
Yeah.
Is that clear, like how I broke it up?
Yes.
Okay, now the only one that might be confusing is the one on the end here. Can you do the first 3 for me? And as a reminder, you can always bring that number out if you want. You don't have to, or you can do it as you go, but let me know. It'd be good for you to work through those first couple.
Okay, I'm done. Uh, 5/. Hello?
Hey, sorry about that. Did you get 5/9, 2/5, and then 1/2, or divide it like this?
I got, yes, I got that.
Okay, great. Okay, now this last one here, okay, it's kind of different. So we'll just come off to the side here, or actually, let me just go up above here a little bit. The integral of a number, so sometimes it's k dx. This always equals k times x plus c. So for example, here, this is going to be 3t because you use this variable here. So the dt is what becomes the t in this case.
Yeah.
Plus c.
Well, and how did you? I think I got this wrong. The
Well, we've never done one like this.
not that one. The t squared over 2.
So it's 1 plus 1 over 1 plus 1.
Okay, and that's it. And
That's it.
okay. Yeah. Okay.
Okay. So the next thing here is this. I guess we should really cover this. If I say like the integral of 4 dx, this becomes 4x plus c. The integral of 5 dt is 5t plus c.
Okay.
So yeah, this 4 goes there, and the dx is what tells you it's an action. The dt tells you it's a t,
Yeah.
and so on. So it's the same problem over here on the right. Let's say I say 4 integral dx. Okay, it's still 4 times x because this right here is what produces the x.
Okay.
Or if I say 5 integral dt, this is 5t plus c plus c. This part of the box is what becomes that.
Okay.
All right, so let me grab another question here for us to look at. Okay, so this question here has fractions in the exponents.
Sure.
Okay, and it's a different letter. It's u this time. It's u instead of x instead of t. No big deal. Let's see if we can get that in there. All right. So no different. You're still using power rule. Okay, just some fractions and some decimals here. So do you want us? Why don't we work through this together, and then I'll give you one like this on your own. Is that okay?
Okay.
So 7u. Now you have to add 1 to the exponent over 3/2 plus 1. See how these are always the same?
Yeah.
Plus 2u 1/2 plus 1 over 1/2 plus 1. Again, the exponent and the bottom are the same, plus c.
Okay.
Okay, so now we do have to simplify. That's an important part of this. 3/2 plus 1 is like 3/2 plus 2/2. So
Yeah.
that becomes 5/2. So it's 7u 5/2 or 5 over 2 over 5 over 2 plus 2u 3/2 over 3/2. And we talked about this yesterday. 7 divided by 5/2 is like 7 times 2/5. You have to flip it. See how this flips?
14 over 5.
14 over 5 u to the 5/2 plus 2 divided by 3/2 equals 2 times 2/3, 4/3 u to the 3/2 plus c.
Okay.
Okay, so let's have you try one here on your own. Integral 6u to the 1/3 plus 4u to the 4/3 du.
Wait, do you add the denominator or no? When you
So the exponent, you add one, and then whatever is up there, this and this are always the same. Let me change the color to make that clear.
it's gonna be 3/3. So
Right. So these are always going to match.
so 3 + 3, 6, or just keep the denominator.
Okay. Oh, okay. No, I understand what you're asking now. Okay, let me go up to the side here. So 1/3 plus 1 is 1/3 plus 3/3. You keep the bottom
Oh,
and
okay,
add the top.
okay.
How are you doing on this one?
Yeah, I'm almost done.
Great.
Much
Great.
better. Wait, if I can't, 6 times 3, 18. What's 18 divided by 4? That's
Well, it reduces, right? They're both divisible by 2, so that's 9/2.
9/2. Wait,
Yes.
so
Both numbers can be divided by 2.
divided by 2. Okay. Yeah, so it could be a fraction.
Absolutely. Yes.
Okay, I got it.
Great. So that, like, you should expect to see a negative, I'm sorry, a fraction on your exam. Like that is a reasonable question. The first two were too easy. You know, this is a little bit harder. So now, negative exponents are also going to appear in some of these problems. Okay, so but it's still the same rule. It's still you add one to the exponent. And so it's n plus 1 over n plus 1, whatever the new exponent is, plus c. So it doesn't matter whether it's positive or negative, or even a fraction decimal.
Okay. It's the same thing.
Yes, same thing. Some simplifying stuff, though, as we talked about yesterday, it might change the sign out in front when you're done.
Yeah.
So this becomes 3x to the -1 over -1 minus 4x to the -2 over -2 plus c.
Yes.
And what does this reduce to? What is 3 over -1?
It's gonna be 3 over -1.
But it reduces just to -3.
Yeah, -3, -1.
4 over -2
It's gonna
is
be
-2, but then there's a negative there, so it's +2.
Yeah. Okay.
Do you want another one like this to try?
Okay, I'll do it.
All right. Okay. Let's do integral 5x to the -6 minus 3x to the minus 2. Yeah, we'll just do that, dx.
Yeah. Okay, I'm done. It's negative 1x to the power of negative 5 plus 3x to the power of negative 1.
Plus c.
Yeah. Okay.
So to check this, again, you just take the derivative. So the derivative, if I do it over here, is 5x to the minus 6 minus 3x to the minus 2, and that's right. Excellent.
I have to do that to show like to.
No. But like I didn't do any of the work, so I was just trying to be helpful.
And can I put like negative 1x instead of negative x? Is that fine, or do you prefer?
This is good. This is good. Yeah, -1's fine. No, it's not a big deal. All right, so next question here that we kind of looked at. This one requires a rewrite before you do it. So the rewrite is 4/3 times 1/t². That's what this up here becomes.
4/3. Okay.
Plus 7/2 times 1/t. That's what this becomes.
Okay.
And then we need to do yet another rewrite.
Then
4/3 t to the minus 2 plus 7/2. Actually, you don't know enough to do this, so let's just exclude that for now. Let's change it. Let's make it that was something to talk about today. Let's make it a 3. So we'll say it's t to the minus 3. Okay, so now try it from here. Okay, we already rewrote it, so it's just applying the power rule again.
Okay. So do I still have to flip it? The 4/3 multiplying.
You have to no, the 4/3 will stay. So this becomes 4/3 out in front, t minus 2 plus 1 over minus 2 plus 1.
That's it? Or
Well, we got to simplify, but if you're, you either have to write it this way or you have to simplify as you go. So t minus 2 plus 1 is t to the minus 1 over minus 1. And the next step here, next thing to do.
Yeah.
I'm sorry, I'm trying to switch colors here. You have to be able to simplify this.
Is it like -1 over times 3/4?
Well, it's like this. There's really a 1 here. So it's 1 over -1. So it becomes 4 over -3, which becomes -4/3.
Wait, so I don't flip it? 3/4?
Nope. Why would you? Because we were flipping fractions on the bottom, not out in front.
So just
Like let's go back. Okay. You were dividing by a fraction here. 4 divided by 7/3.
okay.
That's why you flipped it. Here, it's just a single number.
Okay, so
but it's on the bottom.
I can start with -1/1 times 4/3.
Sure. Yes, that works. And this next one is t to the -2 over -2. So I'll show this in a different color here. It's and you're simplifying this. So this is 7 over 2 times 1 over -2, which becomes 7 over -4 or -7 over 4.
Yeah.
So -4/3 t to the -1 plus 7/2 t to, -7/4 -7/4 t to the -2 plus c.
Okay.
So let's just review this question again, because this is really important. Like, we started with this and we rewrote it a couple of times to make it more friendly. Okay. So should we do, would you like one more together, or do you want to try one of these on your own?
I'll try it.
Okay. Okay. So let me give you one that I think is good here. These aren't supposed to be difficult, but they are, you know, they're new. So it just feels, you know, strange, different.
Yeah.
Okay. So try this one, please.
Okay.
So I'm just writing this rewrite step.
Yeah. Okay, I'm almost done.
Okay.
Okay, the answer is okay. The answer is -2 over 15x to the power of -3
Good.
minus 3 over 8x to the power of -2 plus c.
You got it. All right, nicely done. Okay, so there's one more kind of rewrite that I didn't show you, but after this, we can move on to something new. I think this one's still worth doing. Okay, so this one requires you to remember that the square root of x is x to the 1/2 power. So
Okay.
this becomes the integral 5y to the 1/2 power. So this part right here becomes y to the 1/2 minus 3 over y to the 1/2 power. You follow that?
Yes.
Okay, now we need to further rewrite. We have to make a couple of rewrite steps. Integral 5y to the 1/2 minus 3y to the minus 1/2. So if you bring it up, just like we did in the previous problems, you could do this. So will you calculate the integral from here as practice?
Okay. So it's gonna be okay. Wait, half plus 1/1. 1/1, right?
Yep. So 1/2 plus 1 is really 1/2 plus 2/2, which is 3/2.
It's 1. Wait, I think I got it.
Okay.
Oh, it's 2/2.
Right.
Okay.
Okay, now 5/3/2 becomes 10/3. 3/1/2 is 6. Let's see.
Okay.
All right. Is that all clear?
Yes.
Okay. Okay, so let's talk about some new stuff today. Some new integrals here. So the integral of 1/x dx is the natural log of the absolute value of x plus c. This is something you have to know really well. Okay, so now, like, how else could this appear? Well, if I say the integral x to the -1 dx, this is also the natural log of the absolute value of x plus c, because these two forms are the same. 1/x equals x to the -1.
Okay.
Okay, so now you like, here's how a problem you could be given. It'd be integral of 3/x dx.
It's gonna be x to the power of -3.
Well, no, this is rewritten as
The
3 times 1/x dx.
So it's gonna be
And then
3
that,
x to the power of -1.
but x to the -1. So this, so I would keep writing this until, for now. Okay. So this becomes 3, and then the integral of this right here is the natural log of the absolute value of x plus c.
Okay.
Let's try another one. -6 times x to the -1 power dx. So this -6 can come out. So it's -6 integral x to the -1 dx. And this part right here is that natural log absolute value of x plus c. And then you bring this -6 down. Is that okay?
No, I'm so confused.
Okay. So this power rule, all the examples we've been doing, they only work as long as x is not -1. As soon as x is -1, it becomes this natural log absolute value of x. 1 over x is the same as x to the minus 1 power. This is like a special case. So let me try to explain here. Let's try again here. What is the integral of 1 plus x plus 1 over x dx? So the integral of a constant is always x. Sorry, let me just write x, okay? So this first one, actually, let me separate it here. Maybe that's why it's unclear. Integral 1 dx plus integral x dx plus integral 1 over x dx. So we separate these. So this first one, okay, is just x.
Okay.
The second one here, you have to add 1. So it's the power rule. It's 1 plus 1 over 1 plus 1.
Okay.
But this one is really x to the minus 1. So it's the natural log of the absolute value of x. It's a special like thing that you have to do whenever it's x to the minus 1. Whenever it's x to the minus 1 or whenever x, you have to do this.
Yeah. Okay. What to the minus 2?
Then you use this power rule. So let's do another one here. Let's say it's integral x squared plus x to the minus 2 plus x to the minus 1 dx. So this is integral x squared dx plus integral x to the minus 2 dx plus integral x dx plus integral x to the minus 1 dx. So this one, use the power rule, 2 plus 1 over 2 plus 1. Second one, use the power rule, x to the minus 2 plus 1 minus 2 plus 1. This one, you also use the power rule, 1 plus 1 over 1 plus 1. But this one, because it's minus 1 power, it's the natural log of the absolute value of x.
Okay.
Do you feel like you believe me now? Like you could, like you have to recognize this. Like you have to see this.
Okay.
All right, so let's try one. And I'm gonna kind of disguise it here with some other problems. So let's say I ask you for the integral of x squared plus 1 over x dx. Okay, so we first need to rewrite this. So this becomes x squared over x plus 1 over x. Is that okay? You have to divide both of these by x.
Yeah.
This one here simplifies. We have to do yet another rewrite. Simplifies to x plus 1 over x. Are you okay with that?
X squared, no?
Well, but it's divided by an x. So x squared over x is like saying x times x over x. So some of them cancel.
Okay.
There's also this power rule, x to the n over x to the m equals x to the n minus m.
Okay.
Okay, so use the power rule here. What does this first one become?
Becomes x to the squared
Over,
2.
right, so it's x squared over 2. What does the second one become?
It becomes negative x.
Becomes natural log of the absolute value of x.
Okay.
So that, like, again, there's two things here. It's the same. The integral of 1 over x dx is the natural log of the absolute value of x plus c. The integral x to the minus 1 dx equals the natural log of the absolute value of x plus c. They're the same.
Okay.
These are the same. Okay, so let's have you try one here. Integral 1 plus x to the 4th over x dx.
Okay, so natural log of the absolute value of x plus c uh, plus um, x to the 5 over x
Okay,
plus
so
5.
what did you rewrite this as? That's where we got to start. So there's a rewrite step. It becomes 1 over x plus,
X to the 4th over x.
right. But this you have to simplify.
No, so it becomes x to the 3rd. Oh, no.
Right.
Oh,
So what does that become? Add 1 over.
over 4, then yeah.
So you always put c at the end. C goes at the end. Always.
Okay.
Okay, you ready for another one?
Yes.
Okay. Integral x squared plus x to the 4th over x squared dx. I'm sorry, let me change this real quick. There it is. Okay, x plus x to the 4th over x squared dx. Give that a try, please.
So it's going to be natural log of absolute value of x plus x squared plus c.
Well, you did part of it right. So again, like I got to keep asking, like, what did you rewrite this as? X over x squared plus x to the 4th over x squared. And then did you simplify? What does this become on the right when you simplify it?
Becomes x squared. No.
That's right. Okay, so I agree. 1 over x becomes natural log of x.
Continue. Okay. Okay, so it's going to be the x to the 3rd over 3
Anything else over here?
plus c.
Let's see. Very good. Okay, let's try another one here. Let's make it just a tiny bit more difficult. Integral 3x squared plus 4x over x dx.
Okay. X to the power of 3 plus natural log of x plus c.
All right, so let's rewrite it again. Like I hope you're doing this. I mean, obviously can't tell. This was me being like just throwing in one that's slightly different. So this is 3x plus 4 dx.
Wait, how? Wait.
Well, you divide, right? X squared over x to the 1 is,
Yeah, 3x1.
right? And then x over x just becomes 4.
Yeah.
Okay. So there's no natural log absolute value of x. It's 3x squared over 2 plus 4x plus c.
Wait, how did you get the 4? 4.
4x divided by x.
Okay.
The x is canceled.
Okay, what if it's for x squared?
Well, we're
over-
gonna do one, but you can't like I'm leading you down. I'm trying to help you here with these problems, but like I can't give you them all the same all the time because then I don't know if you're really learning. So try to, you know, even say, hey, this seems different, is it? We can look at it. So let's try another one. Let's try 5x plus 2x squared over x squared dx. Give this one a try, please.
Okay.
All right. Do you have your final answer?
It's gonna be 5x to the power of 2.
Well,
No.
no, it's 1 over x, right? Doesn't 5 over x? Okay, so let me, yeah, so like, did you get to this line right here?
No.
Did you get to this line right here?
I got to this, no, the line after it, but the first 5 over x, I didn't get to this.
Well, there's 1 here and there's 2 down there. So it's like saying 5x over x times x. So if these cancel, you're left with 5 over x. Did you write 5x to the minus 1?
I got 5x to the power of 2 over 2.
Okay, but it can't be. I mean, you've got only 1 x on top and 2 on the bottom. So the 1 on top cancels and that leaves 1 on the bottom.
So I don't find the integral? No.
Well, you do, but it's 5 over x, isn't it?
5 over.
So let's go back here. Let me show you this because this is important. We did a bunch of these in a row. I thought here, let me maybe not. Okay. Let me just pause here. Okay, and do something else. Let me just pause here. The integral of 1 over x dx is the natural log of the absolute value of x plus c. The integral of 3 over x dx is 3 natural log absolute value of x plus c. See how this 3 just comes out in front?
Yes.
The integral of -4 over x dx equals -4 natural log absolute value of x plus c. If I rewrite it, if I say, okay, it's integral 2x to the minus 1 dx, it's 2 natural log absolute value of x plus c. So this 2 comes out in front. This -4 comes out in front.
Okay.
Let's say it's integral of -1/2 x to the minus 1 dx. This becomes -1/2 natural log absolute value of x plus c.
Okay.
Okay, so let's see if we can apply that to a final problem here, final problem or two. Let's say it's a 4x minus 3x squared over x squared. So the rewrite is 4x over x squared minus 3x squared over x squared dx. The one on the left here simplifies to 4 over x minus 3 dx.
4 over x. Then natural log of absolute value of x
Minus, what does this become?
minus 0. Oh
Nope.
no, minus x.
3x
Okay.
plus c. Okay, let's try one more here.
Wait, how can I go up a little bit? I want
Yes.
for okay.
Let's try one more here. Got to get this. Integral 6x squared minus 2x over x squared dx. Give this one a try, please.
Okay. I got it.
Okay.
6 minus 2, not the natural log of absolute value of x plus c.
So it becomes 6x, not just 6.
Yes. That's right.
Okay. All right, this takes us to the end of our lesson for today. Let me know when you're ready to schedule again, and we can find some time to help. I'll send you the notes here shortly.
Okay. All right.
Thank you so much.
You.
Bye now.